Okay, integrated math 3 distance learners, we are talking about remainder theorem today. And what I'm going to have you do to start this off is I am going to write up two questions. So write these with me in your notes. You can draw a new section, new line in your notes. Remainder theorem is the title. And here we go. We're going to do x cubed plus 2x squared minus 11x plus 8. We're going to divide that by x minus 1. Okay, and we're going to have another question. So this is going to be our example 1. So when I refer to it now, we got example 2. Example 2, write this one. X cubed plus 2x squared minus 10x plus 8 over x minus 1. You'll notice that these are pretty much exactly the same. The only difference that we have in these is this negative 11x and then the negative 10x. That's it. So I'm going to pause the video. What I'd like you to do is I want you to do the synthetic division for both of these. Okay. Okay, so I pause the video. You've done the synthetic division. Let's just make sure we've got that. I'm going to go like lightning speed on this. You can check your work. First, we're going to take the 0 from the bottom. It's in that form x minus r. I don't have to adjust anything, so it's a 1 goes here. I list out all the coefficients. We get 1, 2, negative 11, and 8. We're going to go ahead and set this one up as well. It has a 1 is the 0 again. Remember, the only thing different is this negative 10. So it's 1, 2, negative 10, and 8. And here we go. We're going to fly through it. Drop down the 1. 1 times 1 is 1. We get 3 here. 3 times 1 is 3. We get negative 8 times 1 is negative 8. We get 0. There we go. Next, we're going to do the same thing. Drop down the 1. 1 times 1 is 1. Add them, you get 3. Multiply, you get 3. Add, negative 7. Multiply, you get negative 7. And then you get 1. Okay. So the key difference between these two, obviously I said that we changed the number here. But you'll notice how this one has a no remainder and this one does. All right, so that's going to be important. And I want to show you this new rule called remainder theorem. Okay, the title of this section is remainder theorem. So let's say that I gave you these questions and the instructions said, here, let's say the direction said, find the remainder. Okay, well, we did that through synthetic division, but the purpose of this lesson is not so that you can use synthetic division. Obviously, that always works, and you can find the remainder that way, but in this case, we want a faster way to do it. All right, so here's a rule that you can use. We're going to write down like in words what you can do, then we're going to write down something like a fancy definition, okay? So you can find the remainder, so find the remainder for any polynomial division problem or division by plugging the 0 from the divisor into the dividend. There we go. So what does this rule mean? Well, let's clarify. Let's take our example 1 here. Our 0 was positive 1. And let's take positive 1 and let's plug it into everywhere that there's an x. That's what we want to do. So we'll do that down here. Let's see what this looks like. Example 1, we had x cubed, so we're going to do 1 cubed plus 2 times 1 squared minus 11 times 1 plus 8. There we go. This is the rule. That's going to help us. Now we're going to solve this. We just have to simplify it. PEMDAS, order of operations. 1 to the third is 1, plus 1 to the second is 1 times 2 is 2, minus 1 times 11 is 11, and then plus 8. We add all this together, we're going to get 0. Okay? Let's do the same thing for example 2, which was we're going to have 1 again, 1 cubed, plus, hold on, I messed that up. 2 times 1 squared, minus 10 times 1, plus 8. So we do all this. This is 1 plus 2 minus 10 plus 8. If you do that with a calculator in your head, we're going to get positive 1 on that. Okay? Now I want you to notice that we see that these are the remainders. And that's the purpose of this rule. That's what we're trying to get at with this lesson, is that if I have polynomial division, let's say the question says, what is the remainder? This is all you have to do. Just take the 0 from the divisor and plug it into the original equation. Let's write this up in a more fancy notation. So hopefully this doesn't confuse you when we write it like this. We have the basic rule like in simple terms, but let's write remainder theorem. So for remainder theorem, when we divide, I don't like how it's spaced, hold on. When we divide a polynomial f of x by x minus r, the remainder is f of r. This is saying all I have to do is take the 0, the root here, plug it in, and it gets me the remainder. The remainder is always equal to f of r. Okay? All right. So let's look at some examples of how you would work a problem like this. So I have Delta Math up here, and this is the section that says remainder theorem. And what we're going to do is exactly what we just did. We know that we're going to be dividing by x plus 1. What's the 0 of that? Well, it's negative 1. So all I need to do is plug in a negative 1 into the x values. So negative 1 squared is 1, so we get 5 here, plus 1, plus 2, that's 8. So 8's going to go in to my answer here. So this is just, you see how it says, what is the remainder? We don't care about the division. Now you could do synthetic division on this. I want you to practice using remainder theorem because it is actually very important to know it. It's one of our essential standards actually. Synthetic division is going to take you longer, okay? If you don't have a calculator, synthetic division is probably going to be easier for you just because of the multiplication and addition instead of doing like squares and stuff. But if I submit this, I get it right, and that's good. All you're doing is plugging that in. Let's look at another example. Let's get one that's like more oh, here we go. Yeah, this one's fine. So here's one, same idea. We're just going to take this and we're plugging in the root, which is positive 3. So we go 4 times 3 to the 5th minus 3 minus 3. So I'm going to need to know, like a calculator is going to be helpful on this. So 3 to the 5th is 243 times 4. Okay, and then I'm subtracting 3 twice, so minus 6. 966 is what we're going to end up getting for this. That's a big remainder. And I hope I didn't mess this up. I don't think I did. All right, we got it. Cool. And you'll see, so it says even the slow way to do it is remainder theorem or synthetic division. You have to make sure you have your placeholders there. So, you know, you got to be careful with that, okay? But you can just plug this in to get the remainder. That's supposed to be the quick way to do it, okay? All right, so that is remainder theorem. That's what we're seeing here. There's another topic that says remainder theorem. We're going to discuss this in a second. But now we want to talk about factor theorem, and this is the second part of this lesson. So we're already 10 minutes in. We have one more concept that we want to talk about, which is factor theorem. I'm going to be using the same exact examples. So factor theorem. We're going to use the same examples from above, example 1, example 2, but I want to ask this question, okay? If I take 36 and divide it by 9, and I take 36 divided by 10, one of them is going to divide evenly, and one of them is not going to divide evenly. If I know that this 36 divided by 9 is a even 4, and then if I do 36 divided by 10, it's 3.6, okay? And it has that remainder, that 0.6 remainder within it. It's actually, yeah, 0.6 is what's remaining. Okay, so 3 remainder 6, essentially. So, let's talk about what's happening here. With the 9, we sort of at this point, we know that 36 divided by 9 is going to equal 4. We also know, like for instance, if I do 15 divided by 5, versus 15 divided by 6, we know which one's going to divide evenly because we know our times tables, okay? But if I look at a polynomial, let me go back to the original page here. If we looked at these, you're not going to be able to just look and say, oh, I know that's going to divide evenly. It doesn't work that way. Like, there's no, for me, for any math teacher, you can't just look at these polynomials and know that it's a perfect, the word I'm looking for is factor, right? If we go back over here, you knew that 9 was a factor of 36. You knew that 10 was not going to be a factor of 36. So that's really what we're getting at here. This idea of factor theorem. How do we know if something is a factor or not? Okay. So here's going to be our sort of our statement for this. If the remainder from polynomial division is 0, then the divisor is a factor of the dividend. So that's how that works. That is sort of in simple terms the rule for polynomial factor theorem, okay? And we know that from like our simple numbers over here. We knew because this is going to divide evenly, 9 is a factor of 36. I could also switch this to 6, and I know that I would get a 6 here, right? So we know what our factors are because we've studied times tables since like 3rd grade. Okay, we know what factors are, but we're moving that to this more abstract idea of polynomial division. So let's practice one example really quick. I've got so we're going to say is n plus 2 a factor of f of x. Okay, and we're going to say f of x equals n to the 5th plus 7n to the 4th plus 16n to the 3rd plus 17n squared plus 2n minus 8. So how do we check this? Well, we need to know if there's a remainder. Well, what's the quick way to find the remainder? Well, remainder theorem. So what we're going to do is we're going to take the 0. What's the 0 of this? It's n equals -2. So we're going to do f of -2, and we need to see what that is. So we're going to plug this in. By the way, a good scientific calculator that you can use is Desmos Scientific. I don't even think I spelled it right. Yeah, I did. Okay, Desmos Scientific. You can type in whole expressions into this, which is super nice. Let me minimize this. Let me see my equation here. All right, here we go. Let me put that down. I don't need a gigantic calculator. I just need to see this. So it's We're going to use parentheses here. Hold on. All right, so we're plugging in -2. So I'm going to do -2 to the 5th. And then we go plus 7. And here you will want a calculator. There's no doubt about that. This is something that you'll want to have a calculator to help you with. A lot of you will have trouble raising all these powers, especially if it's a number that's not 2. That'd be kind of challenging. So -2 to the 3rd. And we just keep going. Plus 17 in -2 squared plus 2 times -2. Make sure you're using parentheses for all these -2's when you're doing powers. It's so important. Minus 8 and we get 8. 8 is our remainder from all that work. So is it a factor? Well, let's look at our rule up here. If the remainder from polynomial division is 0, then the divisor is a factor of the dividend. Is our remainder 0? No, so we say not a factor. And that's how this rule works. That's all you have to do is just plug in these zeros to check that. Let's write down a very official rule. So there's a little bit to write here. So let's say definition. This will be the last thing we write. And then we're going to do some practice problems on here to help you with your delta math, and then you can start working on that. So definition, when dividing polynomial f of x by x minus r, if f of r equals 0, then x minus r is a factor of f of x. Okay, that's the official rule here. So it's very important to understand this right here. Anytime I'm plugging in a value, we're checking to see the remainder if we plug it into the function. Here's the other, we say likewise, when x minus r is a factor of f of x, then we automatically know f of r equals 0. Okay, so if we're reading a problem and it says we know that this is a factor of this polynomial, that means if I plug in the root, we know it's basically a 0 is what it's saying, and we've talked about that all year long. Okay, all right, so let's look at some examples on delta math of what we're going to get into. We'll start with factor theorem. This work is kind of gratuitous, and what I mean by that is you're going to have to do a lot of calculation to get your answers. So let me show you a speedy way, and you can do this on a TI Inspire, TI 80. We can always type in the first one. So here's what we're doing. Here's your polynomial, and it says which of the following is not, so this is important, not a factor. What does that mean we're looking for? Well, when I plug in the root, so here the 0 is, let me put this on here, there. So let me write out all the zeros for these. So we have -2 is the 0, 2, 3, -1. As we have to plug those into this equation. What are we looking for when we plug those in? We're looking for, it says not a factor. So we're looking for we don't want a 0 in this case. We do not want a 0. All right. So let's go ahead and start plugging this in. Let me show you how you can do this the quickest way. We'll do, let's do x cubed. Well, we're going to do -2 to start. -2 to the 3rd minus 4, -2 to the 2nd plus -2 plus 6. Enter. So we got negative 20. So right off the bat, we're getting one, as long as I typed it in correct, which I don't think I messed that up. Right off the bat, we're getting it correct. But watch what you can do. You can copy and paste and just change it. So I'm going to do it for 2 and just delete. And you'll see, oh, that gets me a 0. Let's do it. Let's paste it again. To do that, you hit Control C, like I'll highlight it, Control C, click down here, Control V on my keyboard. I don't know how that looks on a phone. If you're using a phone to do your delta math, you'll just have to type it in, and I apologize about that. So I'm putting in a 3 here for all these. We already know what the answer is, by the way. 3 and 3. That's 0. Let's do it again. Control V, negative 1. Negative 1. By the way, this is a really great way to save time on tests. All this copying and pasting helps you, like ACT, like on those calculators, they can copy and paste as well. This saves so much time for those types of questions of just plugging in. So again, we know the answer has to be this one here because it was the first one we checked and it does not equal 0. That's what the rule is saying. So I submit that. Perfect. New problem. Okay, so this one is just like the last one, except now we're saying which of the following functions has this as a factor. So we know that the 0, let me write this. We know the 0 is going to be 5. So what I'm going to do is I'm plugging in 5 to each one until, so it is a factor. We need, when I plug this in, for it to be 0. So this is, we're looking for, we want f of 5 when I plug it in to equal 0. That's what we want. That's the rule. Let's go ahead and start doing that. Again, Desmos is your friend. And I'm going to even just take this and I'm going to manipulate it. I hope that's not too confusing. I'm just going to delete all this inside, and I'm going to go back and I'm going to change this. This first one's going to be -2. We're going to do -33 plus 90. And that's very helpful. We're putting in, I need my parentheses. We are putting in, we want 5. So we're putting in 5 into all these spaces here. So that's what's nice about this, is we're not ever changing those. So let's go ahead and let's hit enter on, oh, that got us 0. Again, our first ones are always working now. I'm gonna go ahead and change this just to show it again. I wanna make sure that I show how you can do this quickly. Plus 8, -3, -90. So we're just changing that. That got me a remainder. So this is this second one here. If I wanted to check it, we already know the first one has to be the right answer on this, but I'm just trying to show like how you could change this to quickly. Let's change this to -2, -33 plus 85. That's -5. Okay. Let's do the last one, which is +8 -3 -95. That's 215. So we'll go back to the original, the correct answer, which is this first one up here. To -2, and it gets us 0. So we know this first one has to be correct because we're looking for, is it a factor? So the first one is the right answer. All right, 23 minutes in, we're doing one more question. This is probably the most challenging one on your delta math, or on this delta math. Remainder theorem, factor theorem. So here we go, interesting question. It says, given that f of x equals x cubed plus kx plus 5, and x plus 1 is a factor, when is the value, or what is the value of k? So we're trying to find this value right here. We want to know what it would be. And we're given all this information. We know this is a factor, so we know it divides evenly. So what does that mean the remainder is? So for instance, the 0 of this is how you want to work it. You want to find the 0 of that factor, okay? And maybe it's not a factor always. But since we know it's a factor, we know that if we do f of -1, that equals 0. So let's do that. That's actually going to help us a lot. F of -1 is equal to, let's do -1 to the third, plus, we don't know kx, plus 5. Let me go over a little bit. Plus 5. What does this equal to? Well, we said it's equal to 0. So we're going to put 0 equals, let's go ahead and do this. -1 to the third power, that's -1 actually, plus kx plus 5. Then we're just going to keep simplifying. Let's go to the next row. 0 equals, what's 5 and negative 1? Well, that's 4 plus kx. Then we're going to subtract the 4. We're trying to get x alone now. Actually, we're trying to get k alone. Oh, I messed this up. We need to put a negative 1 in here. Sorry about that. So the negative 1 goes in for x. Remember, we had to do that. Negative 1, negative 1. Okay, I'm actually going to go ahead and rewrite this as minus k, because that negative 1 makes it a negative. So this gets us negative 4, this goes away, equals negative k. How do I get rid of the negative? Well, I can divide by negative 1 on both sides. 4 equals k. So I know through algebra I've solved this. Now let's look at another way to do it, because I've had a lot of people do this in class where they say, oh, well, I know the 0 is negative 1, and then I know that this one it's 1, 0, k, and 5. And they go through this operation. This plus this equals, or they try to do it this way. Bring down the 1. 1 times negative 1 is negative 1. Add these, you get negative 1. And then negative 1 times 1 is 1. So we have 1 plus k, which we don't really know. So actually this method doesn't work too well. So it did work in class when I did this. We know that the remainder has to be 0. I guess that does help. We know that this right here has to be negative 5, right? Because that's the only thing that adds to get 0. So that's actually helpful. And we know that to get negative 5, this has to be 5. Okay, so you can work it this way. That works pretty well too, okay? So that 4 goes in there. So that's a couple ways that you can do this if you think through it. The synthetic division table is pretty nice. I think a preferred method for your math teacher and for me is you want to be using the algebra concept here. But it honestly, for my students, I know that if you're able to think through it this way, that's really good. Okay, it shows understanding of synthetic division in that process. All right. Okay, we're ending the video here. Get some work done on your Delta Math. If you have questions, let me know. I'll clarify those. So we're going to go ahead and stop.